Hi guys, this is a video to help you go over the definitional formulas for variance and standard deviation. I keep using the sample exam I gave you. Excuse me. So this is some data that's about the variability in temperature that you experienced on 5 days of your vacation in Florida, okay, for the first week of July. And I said you were gone for a total of 2 weeks, so this is just a sample. And you list the following days, okay? There's 5 days, n equals 5. So the first thing you want to do is go ahead and get your mean, and I went ahead and just organized the data here from highest to lowest. So there's 5 data points, goes from 83 to 82, like that. If you want to watch the video on how to use a calculator, that's also listed in the videos, part of the module of videos. All right, so I'm going to put 83 in sigma plus, and then it should go to n equals 1. 82 sigma plus, n equals 2, 81 sigma plus, 79, and then 74. Okay. All right. So now I've got them in there, and to get the mean is the second key and the x squared, and so my mean is 79.8. And I wrote that up here, 79.8. All right, so now this is just a matter of doing the math. Okay, so 83 minus 79.8 gives us a 3.2. While I'm in here doing the 3.2, I go ahead and square it, and that gives me 10.24. 82 minus 79.8 gives us 2.2. Right? So all I'm doing here is I'm taking this score, the 81, and I'm subtracting 79.8 out of it, and then that gives me these values. Okay. So then once we're done, you'll see also that we have some above the mean, some below the mean. I went ahead and just showed you that if you put all 5 of these in your calculator added together, that equals 0. All right, so as I went, I squared these. So like negative 5.8 squared is my 33.64. All right, so you add those up because it's the sum of the x minus the mean squared. So the sum of that is 50.8. N minus 1, there's 5 values, so n minus 1 is 4. So 50.8 divided by 4, you're going to end up with 12.70. Okay. So that is the variance, is 12.70. But to compare it to our mean, these are in square root units, and we want to be able to have everything in raw units. So we have to convert it back into raw units, and to do that, we take the variance square rooted. So the square root of the variance gives us our standard deviation, which is represented just by s instead of s squared. So you get 12.70, square root that equals 3.5637, so I've rounded it to 3.56. Okay. Now, on your calculator, this is how to get the standard deviation for a sample is what we did. So to get the sample on your calculator, go second, and the square root key above it, you see where it has that symbol with the n minus 1. And you get 3.5637, 3.56. So if we wanted to do this for a population instead, if we had said these measures are a population, okay, there's only 5 people in the class totally. We just want to know where they are. We're not comparing it to anything else. We just want to know their data. So now we would divide by n and not n minus 1. The top remains exactly the same. Okay. So if we went sum of the x minus the means for population, we use this little sigma symbol, which is what you see on your calculator. Okay. And this represents the standard deviation. Okay. Squared, and it's the variance. So the top remains the same, that 50.80, okay? But we're going to divide by 5 instead of 4 this time. And now we get 10.16. If we take the square root of that, we get 3.1874 or 3.19. To get the standard deviation of a population on your calculator, you hit sigma and the division key, and it's 3.18747, 3.19. Okay, so that's using the definitional formula to get the variance and the standard deviations for both a sample and a population.